So let's begin. Good morning, everyone. Yet another devlog. I'm going to continue solving the Ziglings problems. We were at exercise number 31. I'm going to spend like 30 minutes for this stream. This stream. It's the beginning of the week and I'm thinking about work, so that's why I constantly confuse the stream and sprint words. Okay. Yeah, let's start. Exercise number 31 is what I'm looking for. Switch 2. What's really nice is that you can use a switch statement as an expression to return a value. This is what I was looking for. The if clause. So yeah, this is interesting. The error we have is switch must handle all possibilities. Okay, this is similar to previous one. I think the problem I had there was I almost solved the previous one with the same solution. So yeah, please add the else. Yeah. Note C forces print to display the value as a character. Can you guess what happens if you remove the C? We'll have, I think we tried it. We will have the character code. So we run exercises number 31. Yeah. Is it the character code too? Is it printing the same thing? Let's see, what is this value? It looks like a memory address though. Let's try, yeah, an LLM and trust it. I think I first need to select what I'm going to use. Copilot sonnets, yeah. Then close it. Open a GPTL, yeah. In language, when I print a character like exclamation mark in using print statements without like flow like print like that. What is this value? Is the Unicode code point of the character. Is the character literals, etc. are treated as integer values. To print the actual value, we can use C. If you want to see the actual Unicode value 33, you can use, okay, I need to cast it. That's why. Okay. That makes sense. Let's go to, I think, first mark 31 as result, and let's go for exercise 32. Zig has an unreachable statement. Use it when you want to tell the compiler that a branch of code should never be executed and that the mere act of reaching it is an error. Here we've made a little virtual machine that performs mathematical operation on a single numeric value. It looks great, but there is one little problem. The switch statement doesn't cover every possible value of a U8 number. We know there are only 3 operations, but Zig doesn't. Use the unreachable statement to make the switch complete, or else. Okay, go to here, else unreachable. Zig. This is like erase. Okay, I didn't need. Oh, okay. Zig build. Yeah, you break the lines using comma. This is like raising exceptions, right? When there was a scenario like this in Python, I was usually raising an exception to make sure the program won't be executed. Basically, the outcome of it is to break the program on runtime. And yeah, you need to prevent it by every means necessary. But I think in Zig it's required because you need to make sure the things like this switch statement are covering all the use cases. So if there is no value that you want to cover in this scenario, and instead of raising an error, you define unreachable, which is more explicit. That's good. Number 32 solved. Go for 33. Let's revisit the very first error exercise. This time we are going to look at an error handling variation of the if statement. If foo value, foo wasn't an error, value is the non-error value of foo, else error, foo was an error, error is, okay. Is ERR a special syntax here? Or when you use this, I think it's the pipe syntax, which is indicating that we are handling errors. Yeah, I'm going to test it later. Let's first focus on solving the challenge. We are using a switch statement on the error. Okay, we just don't have a block. We use switch as a block. That's fine. And then here, if n value, print the value. If else error, switch on error. Put it as a match for too small here and have it print less. My number too small. Let's see. Actually, print the complete is easier. It should have worked. That's because I need to automate this. Yeah. Less than 4. And then I was reading the Zig book that I mentioned in the first stream, the Introduction to Zig project-based book, and I learned about this syntax why we are putting a dot here. Dot actually is indicating that we want the type of this object to be inferred for the required value of the print function. So we don't need to actually initialize the value. This was a clever syntax I planned. But let's focus on solving the problems they built. Yeah, number 33 also resolved. Now I wanted to check something. If for here, can I do age last rename ERR to E? This is still compiled, right? 033. Yeah, there is no problem. So ERR is not a reserved keyboard. It's the syntax that indicates if it's a value or error. Interesting. Number 33 resolved. Let's go to 34. Quiz number 4. Quiz time. See if you can make this program work. Solve this any way you like. Just be sure output is my Enum 42. What is the error first of all? Expected type U32. Found error illegal number. Okay, this is the problem here. The easiest I think is to have it run exercise 34. Expected void found error. Yeah. VS. Okay, now it's solved. There is, of course, other ways to solve it as well. I can do do I need to do anything extra? Yeah, I don't feel like it, to be honest. I can do the if clause I learned. I can do catch value, because this statement will never happen, right? So the very verbose way of doing that would be, actually maybe that's not a bad idea, because when you do try, you're opening the opportunity for main function to also fail, right? Let's see if I can remove this and guarantee that the main function will always run, right? And having the knowledge, which is not reasonable, to be honest, that's not a good idea, because then I'm designing it against the internals of this function. But anyway, let's try that. If I do if, I don't want to have a default value, otherwise I could use the catch. Actually, catch could also be a good idea. I could do get number catch unreachable. This is also possible. Expected typo found error right failed. Okay. How about doing the if statement? If get number value. This is embarrassing. I need to check the previous one. The thing is now I cannot return the value. I cannot then I need to assign const inside this. Const my num equal to value. Go here, dig like this, else err. Then I can make it more stable to just expect that this type of error won't happen. Say number or illegal number. This should be unreachable. Would this compile? No, in any case, I need to always, yeah, because this unreachable itself is raising an error, of course. So my only option would be to, yeah, set a default value. Let's go back to where we were. Catch 0. Only in this case I can. Oh, I this should be U32. That's because also this function has a try statement. That's inevitable then. What if we didn't have this? Unused local. Let's discard this. Also steady out. Okay, now it compiled, but there is no guarantee that it's running because Zig is lazy. Okay, maybe in future I will figure this detail out. If there is such a possibility to prevent a function from raising an error. But I think the syntaxes I use should be reasonable. Unless for unreachable you need to guarantee the type. That might be the case. I don't just know how to test that yet. Okay, let's move on to the next problem. I think that's something I will learn hands-on. Number 34 result. Let's go to 35. Remember, that is a mathematical virtual machine we made using the unreachable statement. Do you remember it? Yeah, of course. Well, there were two problems with the way we were using opcodes. Having to remember opcodes by number is no good. We have to use Unreachable because they had no way of knowing how many valid opcodes there were. And Enum is a Zig construct that lets you give names to numeric values and store them in a set. They look a lot like error sets. And then, okay, let's use an enum in place of the number we were using in the previous version. Please complete the enum. Okay. I see ink. I see paw. Paw. And dick. Okay, then here we have the operations, increment, power, and then for each we have switch a statement, and then no else is needed. This is interesting. Okay, so if the statement used in switch is a known type, then you only need to cover all the types related to that statement. Otherwise, it's 35, 035. Yes, okay, so it knows what it's not covered, what we didn't cover. That's good. I cannot type today. Okay, refill. Let's go for number 36. Enums are really just a set of numbers. You can leave the numbering up to the compiler, or you can assign them explicitly. You can even specify the numeric type used. Okay. You can get the integer out with a built-in function, int from enum. We'll learn about built-ins properly in a later exercise, that's fine. And then that's a U8 value. Note how the built-in function starts with add, just like the import. Yeah, we use another one, I think, as well. Zig lets you write integers in hexadecimal format. Web browsers that has a specified color using hexadecimal number, where each byte represents the brightness of red, green, blue, where 2 hex digits are 1 byte with a value range of 0 to 255. Please define. Yeah, this I know. 0x0, we want to have 0x 0000 ff. Remember Zig's multi-line. Remember Zig's multi-line strings. Yeah, these kind of questions I have problem reading them. Here they are again. Also check out this cool format string. Colon is separator, then padding, alignment to the right, with the width of 6. So x colon 0 bigger than 6. So we are printing in hexadecimal, we are padding it with 6 zeros, and the alignment is on the right. Okay, I think I will figure out when I need it. In high-level programming, usually that's not the case, unless you want to be fancy on some CLI points, which didn't happen that often. Exercise 37. No field name health. Being able to group values together lets us turn this into this. Okay, the point above is an example of a struct, short for a structure. Here's how that struct type could have been defined. Yeah, XYZ, yes. Let's store something fun with a struct, a role-playing character. We'll use an enum to specify the character roles. Okay, please add a new property to this struct called health and make it u8. Health u8. Good. And then fn main, yeah. We are creating character. Glorp gains some gold, add gold. Gold takes a punch, health reduced by 10. Was there any... Wait a minute. Default value for health? No. We have roll gold experience set, but no health. Then would it become negative 10 immediately? It start from 0? No. The health should be... Yeah, please read the fucking document. Health should be 100. Big deal now. Good. 36 and 37 both sold. We are going for 38. Grouping values in a struct is not merely convenient. It also allows us to treat the values as a single item when storing them, passing them to a function, etc. This exercise demonstrates how we can store structs in an array and how doing so lets us print them using a loop. Okay. We have the character, we have the role, then main, glorp device. We are making the... Okay, this, we know we can have two characters. We have not defined it, so we define the first one down here. Please add zomp with the following properties. Oh, these are the memory values. Okay. That's probably why in the book it was indicating do not use undefined as much as possible. Make sure you initialize the values, the objects you define. That's fine. And then now here's one equal to character, and then here role would be role dot board dot gold is 10, that health is 100, and experience is 20. Feel free this is it. Feel free to run this program without adding up. What does it do and why? Yeah, this is what it does. It's basically printing out whatever I have in my RAM in those related, the expected address related to this object. But now it should be solved. Yes. 39 is the next one. Check this out. Where foo bar is a pointer. What is a pointer? It's a reference to a value. In this example, bar is a reference to the memory space that currently contains the value 5. So the memory address of a variable we use ampersand, and a cheat sheet given the above declaration. U8 the type, the value 5, the type of a pointer to U8 value, reference to, and to dereference it, use data star. Okay, this is now less confusing than C. You'll see why pointers are useful in a moment. For now, see if you can make this example work. So we have set num1 to 5. Num1 pointer is this. Num2 is undefined. Please make sure num2 is equal to 5. Using no, okay, this is easy. Num1 pointer data star. I'm dereferencing the num1 pointer. And yes, that worked. There are some details that I learned today I believe I need to review, but pointers are not one of those. This was quite straightforward. That's a good sign. It's important to note the variable pointers and constant pointers are different types. You can always make a constant pointer to a mutable value, but you cannot make a var pointer to an immutable value. This sounds like a logic puzzle, but it just means that once data is declared immutable, you cannot coerce it to a mutable type. Think of immutable data as being volatile or even dangerous. Zig always lets you be more safe and never less safe. That's reasonable. What is the problem here? I don't get it. Given var who you a type and who is a star u8, yes, and bar of type okay. I can let it be inferred, right? And hopefully eglot. No, that's not what I want to do. I want to do eglot restart. Okay, that's how you define. Yes. So to solve it, I should use this syntax. Okay, interesting. So to define the pointers for constant variable, you also should use the constant pointers. Okay, that's reasonable. I think that's it for today. Yeah, maybe in the evening I'm going to give it another chance and solve a little bit more exercises. I'm happy that I reached my goal today. So please feel free to like and subscribe, and have a nice day.